Quorum. Good morning, welcome everyone. We'll continue with our distributed VOQ review. We did the second part of the review yesterday, and we'll continue with the HLD review today. Please take it away, Shrikant.
Okay, thank you, Anshu. Thanks everyone for joining. Just a quick recap of the changes to the document based on yesterday, and towards the end of the meeting yesterday, probably a few people left earlier, so we probably might recap the last 5 minutes of that discussion, and then we'll get right into it. Right. So one change from yesterday is that we updated this picture to reflect the location of the configuration for system ports. Instead of the system port configuration being earlier being in the supervisor card, it is now expected that it is made available as part of the config DB for each ASIC. So that's one comment from yesterday. Then the other change is to section 2 here. Based on the same thing, the workflow or the flowcharts call flow has been updated to show that it is being processed locally in each ASIC instance. The config for the switch has been also added. We added max cores to the switch configuration, the ASIC configuration, instead of it coming down from the VOQ from the central configuration. Another small change is to the name of the system ports. So the system port table, the system port itself in the config DB did not change, but we added another option where you could cross-reference the name of the local port if the name of the system port was going to be different from the local port name. This is shown as an option to allow some discussion, or if you want to take this, or if you keep what's already there, right? I don't know, Suresh, if you want to add any more comments to that.
Yeah, I think one question for the team and members here is that so the system port config, if you look at, there are two choices we have. One choice is that each line card or like each SONiC instances can have their own port names, like a local port name. Today in SONiC, all the SONiC instances or line card or a piece of box has a port name starting with Ethernet 1 or Ethernet 0 to all the way to the maximum ports it can support. Then, so when we have system port, the system port can be reused from the local port name, or we could have a system port as a separate name and create a local port as a reference. Rather than as mandating that the local port should be unique across all the SONiC instances. So that's one question, but we prefer, I mean, we are okay with either choice, but our preference is like the second choice if possible. So just want to check any opinion on that or any comments on that.
I think this, to me, this is just mainly an operational question, right? Like if you're dealing with what is easier, and I think mostly this is probably.
It also probably goes to port config.ini that you don't need to generate the port config.ini differently.
Yeah, exactly. Right. So that's one part, right? One part is when you're trying to provision each instance, right? So would you, it may be useful to say I have the same model line card in slots 3 to 8 of a box. Then if I can use the same template and use the same naming scheme, then it may be easier to provision, right? But on the flip side, if I'm just looking at a port on the device, if I say Ethernet 1, then I have to always be aware that it is either like line card Ethernet 1 on line card 1 or Ethernet 1 on ASIC 1 or what on line card 1 ASIC 1. So that awareness needs to be there when I'm kind of, you know, working with that port.
Yeah,
I think that is where the choice comes in. So I totally agree with what Suresh and said. It's just a choice. Like it's whatever's operationally preferable for an operator is what I think what matters most.
Yes, yeah. I think at this point it's a question of
SONiC uses something called alias. So the alias can be something we can be little descriptive, but the name can be something like because the name is what the net devices are created. So some reason the net devices are in the kernel, and kernel has some restrictions, right? Like it cannot have in the forward characters and backward characters and all those things. So so the names are today is simple, like Ethernet 1 to 36 or 72 or whatever 48. And so that's the reason I mean I'm thinking it's like option 2 and we can support both ways, and it's a choice of config to create same name or different name, but we don't need to mandate it from architecturally or as a chassis support. Yeah. So otherwise they can go with the alias. The alias is one descriptive form. But a multi-ASIC, I think the multi-ASIC approach, they did name it contiguously from port number 1 to whatever number of ports on that box. So
yes, so we just put this up here just to see if there is a sense that we could make a call on this now, or it could even be left open. Right. Just wanted to make sure we had a chance to discuss this.
Okay, so this only matters when we try to create the NetDev for the system port, right? So if we're not going to create those NetDev for those system port, then if they just stay in the DB, then it can be those more descriptive names, right? So
yeah, so the way one proposal, if you look at the name, can be Ethernet 1 slot 2 and ASIC 0 or ASIC 0 slot, port 1. Basically that will be like this name, the name will be look like this. If that's something like you're okay with that, we could approach that way, but the name will become like, it will include the slot as a slot rather than, because there is no forward character what we understand from a kernel, or we got to patch the kernel.
no, I think the name, I think they have that restrictions, right? So, but my point that only when you, this is depending on the discussion whether we're going to have the system port in the Linux kernel or not, right? So if we are not going to have them, then if it stays in DB, it can be those hierarchical names.
Okay.
So
even maybe we could then.
I think the point is we can park this discussion until we converge on the other.
Yeah, that's okay.
It might be better to finish that and we have all the context.
Yeah, exactly.
Okay, so that was one change. In the config DB schema again, max course is added to the device metadata. Then the system port, it hasn't changed. There's no change to the schema there. VOQ DB, so we removed the system ports themselves from the VOQ DB based on yesterday's conversation that it's directly in the config DB. We removed the ref ID from the system port interface table, given that at this point there isn't a specific known need to have it. If it needs to be.
I saw there's some server IP and server port you mentioned somewhere.
Yeah, the server IP, server port were there even in the earlier version too, right? You would still need this to synchronize your neighbors, dynamic neighbor information, right?
This is the Redis server running on the control card or supervisor card. That's IP address of it.
But that information we have in another file also now, something called database config. So I'm not sure.
Oh, is it?
We need it.
Yeah, it's there in the.
Not good enough, because you need the line card instance needs to know what this information should be so that it can connect into the chassis DB if needed. That's my understanding. If there's another way.
So that is correct, Karthik. I think Abhishek is right here, because we have to build in. There's a kind of like a object used to access the database, and that is built in the JSON file, so which describes exactly how to connect to the chassis DB. Right? That's
a quick note. This is Veda from Nokia. So that IP address in the config DB is mostly for kind of accepting connections from different interfaces, right? So it's not like the destination we want to connect.
I think that's Redis server IP, correct?
So one is where the one is where you start your server. That is a server, local server where you're running, the endpoint you call it. The other is this one is where you want to connect to, right?
Yeah.
So we could probably make it, but it's in the VOQ section, right? I mean, I guess the VOQ context is probably not clear in this table. So this is the VOQ chassis DB server, right?
Yeah, I'm not sure. Yeah.
We'll take a look at it.
Sure.
Maybe we'll take if there's some configuration exists for any. So what I understand from Abhishek, you are saying that is there a way to even today to configure SWSS to connect to any Redis server rather than because there's a multiple.
Yes, because that config file, maybe I think Judy can correct me. I think, but that takes the port and the server we want to connect to.
But this is two different. I mean, this is two different servers, right? Here it has to connect to multiple Redis. So as long as it's array of Redises, it can need to connect. It knows that this Redis means this purpose. Because we didn't look at the recent that 3 Redis changes happened, but we'll take a look at that.
So if you could, if you could send us a note in the chat group or a reference, we could take a look and see if that meets what we need to do here.
Okay. Yeah, as Abhishek was telling, I think I also just sent that link to you. So because we recently introduced that way of like connecting to multiple databases in different namespaces. Like if you think of multiple ASICs in a line card, which is like mapped to namespaces. So the application can talk to any Redis DB. So we have config files, JSON files for that. So maybe we can expand on that into the chassis level also, so that anybody can talk to the Redis DBs running in multiple line cards as well.
That makes sense, yeah. Because VOQ DB is more like a config DB and most. I mean, one type of DB. If you can, if today I think we run into 3 Redis server serving different DBs. So this is one of the DBs, yeah.
Yes, yeah, I think that's a good point, I think, Abhishek, because we actually have the infra outside to talk to different Redis DBs. Yeah.
So we'll take a look at that, and probably this can go away then.
Yeah, sure, thanks.
Okay. So the other change, VOQDB, we removed the ref ID from the VOQDB because at this point there is no known requirement to have it. If such a need be found, we could add it back. This was again taking the comments from yesterday. VOQ neighbor table, no change. So the system port channel tables here, right? So it's a lag and switch ID. Based on the comment yesterday, that could be put the switch ID so that we know exactly what to do with it. So the VOQDB schemas are again a reflection of what's described above, right? So there's nothing really different here. So with that, we were reviewing section 2.6 yesterday. We could go there, right? So we took the last 15 minutes yesterday to kind of go over section 2.6 or 2.6.1. If I think a few people left towards the end of the meeting, so just to summarize the comments there, option 1 is effectively the programming of the records, interfaces, neighbors, routes in the kernel matches exactly what is programmed inside. And we would create net devices for all the system ports in this model, right? And if, for example, if somebody had a lag, you would also end up creating a net device for the lag. I don't see the lag example here. The first table and the packet flows show what happens from a SONiC communication between SONiC instances over the IP stack. It shows the net devices representing the CPU port of every ASIC. There's no lookups happening in the ASIC. The IP stack in the SONiC completely determines where the packet is going, and the SI host interface driver can then put on the right headers to drive the packet to the destination system port. Right. And the next stop resolution, as we said, completely happens in the kernel IP stack, and the ASIC does not need to do anything. The second part of the same option is an example of what would happen if you're going out on the front panel ports.
I have a question on the option 1. So is there going to be a net device for the fabric ports?
No, fabric ports do not need net device because there are no IP hosts that are reachable via the fabric ports, because fabric ports do not terminate into an IP unless it leads to another system port, right? So we wouldn't need it.
Okay.
Yeah, the fabric ports are just a transit between the ASICs. There is no termination of that traffic anywhere.
So one question here. So when we say system port, it will be all front panel port plus all the CPU ports for each ASIC?
That is correct.
Because currently, I don't think when we create a port, we create a CPU port in the side.
So we do not. So that is part of the proposal, that we do create a system port. I mean, you technically don't need to create a host interface for yourselves, but you do need to create a system port for the CPU port.
Okay. So basically, a system port. In general, when we create switch, will pass a system port for the CPU also. Then.
That is correct.
Yes.
Okay.
My understanding is that, at least what I looked at, is like today there is no explicit call, but it happens implicitly inside the implementation for the CPUs.
Right. So the system port list, or the configuration for the system ports, that should include the CPU ports and the system port ID assigned to the CPU ports.
Okay, thanks.
Okay, so the second part of option 1 describes how the route tables, the ARP records, and the interface tables look in the case where the communication is happening over a front panel or the network ports over different ASICs. So when we wrapped up yesterday, we just finished describing how a packet flow goes from, say, SONiC 0 out of a network port of SONiC 1, and from a network port of SONiC 1 in the reverse direction to the SONiC instance 0's IP stack. That's where we had left it. I'm not going to go over all the description again, but if there's any questions, we can kind of discuss it now, or if they're not, we can discuss option 2.
I think, do we want to go through the packet flow one more time? I think that's probably instructive too. Yeah.
Okay, thanks. I'll do that.
Yeah.
So the packet flow here is, let me take the packet flow going from SONiC 0 out of, say, port 1 on SONiC 1, right? So the kernel routing table will resolve, say, to a, and I'll say to a prefix, to an IP address in the prefix 11 range, right? So the kernel route for IP prefix 11 will drive the traffic, or the kernel will drive the packets towards the net device ASIC 1 port 1. And the SI host interface driver takes that packet, injects it into its CPU port interface with the right set of headers that will cause the ASIC to forward the packet over the switch fabric, because it will address it to the system port of port 1 on SONiC 1. So it will drive the packet through this interface, the switch fabric, and it will go over port 1, right? So the packet is queued, everything. There is no egress header termination or editing happening for these packets, right? The complete packet is constructed by the originating IP stack.
The other kind of, just to make this point, is this: once the packet hits, once the system port is selected, the packet flow is exactly the same as it would be if a packet came in on SONiC 0 port 1 and was routed to SONiC 1 port 1. Correct?
So no, it is not the same.
Once a system port is selected, I want to be very clear about that. Right. Once a system one.
Yes, but there is a header rewrite happening in case it's a routed packet, whereas in this case,
yeah, that's a good point.
The header rewrite
that's right.
is
That's
not
what,
happening.
no,
right.
I take that back. Yes, yes.
I don't quite understand this. Why there's no packet rewrite in the hardware?
So because the routing table in the kernel here has the complete information for the neighbor across port 1 on SONiC 1, right?
Sure, but then how do you bypass the egress pipeline of the ASIC?
So you're not bypassing the egress pipeline. You are sending the packet with a standard send a packet out over a port. It is not going through the routing portion of the pipeline, right? You're not putting an NCAP ID on the packet or anything. So when a packet is sent to the egress pipeline, you could send it saying that you require layer 3 processing on the egress, and here is an NCAP ID. Or it could be also sent to the egress pipeline saying, just send it out of the port. You don't need any header rewrites, right?
Oh, so what type of processing is this then from the ASIC point of view?
So from an ASIC point of view, this processing is really no different than as if it was sending it out over its own front panel ports.
Yeah,
right?
That's the point. Yeah, I mean, if you think this is a local port, if you think every port is a local port of that CPU, it is as good as that. Like we directly write to the port from the CPU.
So yeah, so from a packet editing point of view, there is no difference between this going out of a port of another ASIC versus port of the local ASIC.
So this is really basically saying that you're skipping the ingress processing. As soon as it hits the fabric, it goes to the other side and it will carry out with its egress processing, right? There's no difference between coming from.
I think it's even more than that.
CPU.
Right? It's
more than that.
There is actually no egress. There's no packet processing at all. Like there's zero packet processing.
So you probably process the QoS and determination of the queue and other things, but there is no forwarding lookups or header modifications.
Those are done at the ingress, right? The forwarding decision has been done on the ingress, but on the egress, you can still go through, let's say, some kind of ACO, egress ACO, and all that, right? That still needs.
Right. So it is subject to those if such an ACL is on egress, right? So I think the important thing is that the ingress
I'm not sure, Srikanth. At least that is very architecture dependent. I think we should be. This is a good point.
It could be that depends on an architecture whether it allows or not. The important thing is that the ingress is not giving a specific directive to egress to do any header operations.
Yeah, I think this is actually a very interesting area to kind of explore a little bit, because I think what really matters is what context is carried in the fabric headers between the ingress and the egress, right? And so depending on so basically it says whether the packet needs to go through just queuing and forwarding, which is a raw operation, or it needs to go through intelligent packet processing, which could be rewrites and or other packet processing operations like egress ACL. So I actually don't know, and if we can safely assume that you'll basically get all or nothing behavior. I think you'll either have to have all the egress packet processing take place, or you'll have to have none. And that is a detail that has to be.
Right. So I think the important thing is that it is no different than how the packet would be treated if it went out of your own front panel ports. Right. I mean, everything that we said.
Yeah.
I mean, there's no difference. I mean, if for example, in a pizza box, you're sending out a BGP packet out over a network port of that pizza box, it would be the exact same treatment, even if it goes out of the network port of another ASIC.
I mean, and also this architecture, right? It is not that just because the net devices are created doesn't mandate that the pipelines are skipped, has to be skipped. It is up to the KNet drivers of a particular Linux KNet driver implementation to enforce how this injection works on that particular network interface card, right? So it is what we are what we are talking. I mean, we know that from one of our architecture, or like one of our knowledge base, saying that, I mean, common implementation is like that. However, we cannot say that just net device exists means that it is it is skipping the NIC processing. There could be NIC processing happening anyway. Yeah.
So actually on that, it's probably the architecture is a little more stricter than that, I think, because the processing we described here for picking a port is the exact same. For example, if you're sending an LLDP packet versus an IP packet, right? For example, when you do send an LLDP packet, you send it with an expectation that nobody is touching that and it is going out without any checks, right? It is the same kind of an expectation here. I mean, that the KNet, when you pick a port and say send it out, that's what it means.
But but I guess the point here is not, for this schema, it's not really try to mimic what would be the front panel port forwarding flow and try to exactly replicate, because it's different, right? So there is no egress processing. I guess the point, that having this approach is to try to make the control plan programming, the kernel programming same as the DB programming. I guess that was the point. It's not really
right.
about.
It more kind of aligns with what was done so far. Does not necessarily means it's better or worse. It just says it kind of matches what's there, right? And does not require us to think differently there.
The control plane, I mean, that's the point, but there is slight difference between, if I have to compare this with fabric port as an IP fabric port, IP fabric port, and the states are replicated in the kernel, though that the states, the net devices doesn't really belong there. The reason we do that is just to get the data path working. Beyond that, there is no reason to populate this. I mean, so it's kind of yes and no, Guhan. It is mainly for packet forwarding, then the control plane convergence.
I have a quick question about the encap ID in this case. Who is going? Okay, so is the kernel is going to supply the encap ID? Or who's going to?
So I guess in this case, the encap ID is not needed because the kernel has resolved the neighbor fully down to the MAC address of the neighbor, right? So when the packet comes out and is delivered to the net device, it's got everything already.
So it actually knows the exact system port that needs to go out.
It knows the exact system port and the MAC address of the neighbor, right? So technically, the encap ID was only required because the header rewrite was needed on egress for a routing flow. This one inside the ASIC is not a routing flow, right? It just send a packet over a port kind of flow.
I had one question on the lag. So, in case of when SONiC 0 injects the packet, which will KNet driver use? Because the lag could have multiple system ports.
Right. So the picture doesn't show the lag, but I can probably talk through it. So in case of a lag, say there is a lag with port 1 and port 2 of SONiC 1, right? Is that your example?
It could be same line card, different line card, right?
Okay. Yeah. So port 1 and port 2 of SONiC 1 are in a lag, and SONiC 0 needs to send something out of there. I mean, the expectation is if you're picking this option that there is another net device, the Linux bonding interface is created. And then port 1, ASIC 1 and port 1 and ASIC 1 port 2 are added to the Linux bonding interface. And any of the neighbors and next stops and routes are then programmed against the bonding interface. So the kernel bonding driver, when you're sending a packet out, resolves and picks the port for transmission. And once it picks the port for transmission, the rest of the stuff happens as I had just described, right?
No, so that's where I had a doubt. So like the RIF is on the port channel, right? So, but when we inject the packet to the ASIC, we actually have to set the system port of a physical port for it to egress out. Right. So how do we pick which system port to use?
So that so the KNet itself is not, the lag is not created in the SI host interface driver. I believe the SONiC model is to actually use the bonding interface that comes natively with Linux as opposed to using a lag interface from the SI driver, right? So, so from the way it would work is you would create a bonding interface in Linux, and then you also create SI host interfaces for those ASIC 1 port 1 and ASIC 1 port 2. Then you would add these two host interfaces to the bonding interface as members. So when a packet is submitted for transmission, it is submitted to the bonding interface, and the Linux bonding driver resolves the port for transmission.
does that ensure that the same flow will pick the same port always?
So I believe that's how SONiC does it today for a lag. I don't know exactly what the logic is, but I'm assuming that part's already taken care of, given it's an existing design choice.
Yeah,
it's a team D, right?
But I think the difference here would be that you know, on the SONiC 0, it's not really going to having this dynamic lag, right? So because ASIC 0 is not going to talk to those neighbors directly, so it's you know, we couldn't enable the dynamic lag on SONiC 0. Only on the SONiC 1, the dynamic lag protocol would be enabled.
So Guhan, the way this would work, the way this would have to work is that so we are already exporting lag membership state, right? Like from SONiC 1. That needs to happen even to program the data plane to do lag expansion. Right? The same operation would have to also modify the bond relationship to say, when, for example, if I have a 2-port lag on, like if port 1 and port 2 were member of a lag and port 1 went linked down, then that information would anyway have to be conveyed to SONiC 0, right? And SONiC 0 would update its hardware or data plane lag membership expansion table to exclude port 1. It would also have to modify the bonding relationship, and the net driver on SONiC 0 would have to expose a IOCTL where you can, like, I suppose you don't need you basically have to have a support for an operation where you can at runtime modify the bond relationship. That's
It's like the bound will be kind of a static bound, right? So but the maybe some manager will need to manage that bound relationship based on the database, the chassis database informations, right?
Right. So if you took option 1, you would, whenever you get a BOQ port channel member table update, you would go change the bonding membership in the kernel in addition to whatever else you do with SI. Right?
So which means we need support for static lag in that case, right? In SONiC.
So I guess from a TeamD, so this could probably be all managed outside of TeamD potentially, that you would not need to touch TeamD for this, right? You're just programming, because TeamD is only kind of running things locally on which you're possibly running LACP on the ASIC. But you're right. This looks like a static lag for all practical purposes on the other ASIC.
We didn't. Yeah, I mean, so question is that we didn't look at very carefully with the TeamD. Is it managing the static as well in SONiC? But if that is what is already managing static, then TeamD can be used. But we didn't look at specifically the TeamD side of it. So we assume that there is somebody can be done, as Guhan was saying, that there will be somebody to manage the static lags coming from a DB.
Okay, so just sorry, I wanted to step in here. It's like we're half an hour into the meeting, so I think it would probably be worthwhile just kind of looking through enough of the option 2 so that we don't kind of get lost in this, right? Because again, it keeps coming back to how do we pick one option, and you know, if we don't see enough of option 2, it's probably hard to get to a resolution. Right. I'm just trying to be respectful of trying to converge.
We could go to option 2 and come back. Did anybody want to look at the reverse packet flow, or should we go to option 2 before we do that?
I think it's worth to also tell not only reverse, right? Srikanth, the flow to, like, for example, an SSH to work.
Right. So with this model, there is really no difference at per application difference, right? I mean, there's absolutely no difference in individual applications. It is just an IP application at this point. SSH or any other IP application would just work. I do not know if that is necessarily a difference between option 1 and option 2. I think they'll probably, we are ensuring that there is IP connectivity in both cases and not have application specific restrictions.
Yeah, both cases, yeah. But the flow is like data path point of it. I mean, in option 1 and option 2, both is possible, right? Yeah.
Hey, I have a question, right? In this option 1, when the NetDev, does it have IP address associated with it?
It only has an IP if the port is local.
So when you receive a packet from a different ASIC, does the kernel know how to?
So I think as long as the MAC address belongs to that ASIC, that namespace, you would be able to handle it basically. When you create the net device, you specify a MAC address for that. If the destination MAC on a received packet matches that, the kernel can handle the packet.
Here, everything else.
So I mean, I think there's one issue that still is uncertain for me, which is that if a packet comes in on port 1 of ASIC 1 and gets sent to the CPU port of SONiC 0, at least this current Jericho 2 chipset is going to have a problem with it, I think, because the egress editor for packets going to CPU don't actually do the packet rewrite. They preserve the entire system header.
Right.
So I think it's not a real routing operation.
Right. If we cannot get past that limitation, it would mean that you would end up using the same MAC on all ASICs with this option. Right. I think if that's a specific limitation or an issue that cannot be worked around, it would mean it would force all ASICs to use the same MAC, which would be a bit suboptimal, right, in my opinion.
That's kind of chassis MAC, right?
Right. Yeah, but I mean, in ideal, you don't want a restriction. You would probably make it a choice to use it or not, right? So.
Hey, have this been prototyped or proven or not yet? It's just.
I guess to that we've prototyped both options. I believe both will work. There are some restrictions I think we discovered when we tried prototyping option 2 as described. I can go over what we ran into when we discussed option 4.
Okay.
Sorry, I didn't get that part. So, like, I just wanted to check, did this thing work, the reverse path, when you tried it?
So the reverse path worked. So I think your observation was correct on Jericho 2, that as of the delivered implementation, it doesn't do a header rewrite, right? What we do not know is if it is an issue that the vendor can fix or if it is something that is a hard restriction, right? I mean, we have not, we have raised a case and it has not been turned down, so they are still looking at it.
But this architecture, sorry, take more time. Is this very hardware specific? Like,
not architecturally, it isn't, right? So effectively, you're saying it's ports and everything is a system port, and you could route in and out, right? So technically, there isn't a bug in the implementation might make it architecture specific somewhere, but I mean, as it is, if anybody can route, treat a packet going to a CPU as another system port, it wouldn't be architecture specific. Right?
I mean, the challenge is that any chip you take, packets to the CPU are handled differently from packets to other ports, right? Like it's fundamentally packets to CPU needs to preserve the system header so the driver can deal with it appropriately.
So there are some special capabilities with the CPU port, and I think we are kind of working on a statement saying that CPU is, in addition to everything else, it is also a system port, right? If that assumption doesn't bear out, maybe the restrictions like the one that we just talked about with the MAC address will pop out. I mean, so far we haven't seen outside of the MAC address, which may or may not be a bug in what was delivered to us at the point, be an issue, right? So it's the jury is a little bit out, but the packet flow outside of that completely worked.
Okay.
So let's get into option 2 here, right? So the fundamental difference here is that you'll start seeing differences between what is in the kernel and what is in the SI, right? So in this case, I actually show both the SI tables as well as the kernel tables, right? So the difference is only in the neighbor tables. The route tables, which use next stops, really don't change. So at a high level, the proposal says instead of pinning a net device against every system port and creating it in every namespace, create it only for the network ports of the ASIC and one additional port, which we're calling the CPU port. And that the proposal, as it says add the CPU port to a VLAN, and then all packets received against that would be classified as being received on the VLAN or on the CPU port. At this point, I must admit that we did have trouble prototyping this exact model. The trouble wasn't in the transmission side. We could transmit out and the ASIC completely did the lookups and forwarded. But the trouble was on the receive side, where the SI host interface driver seems to be incapable of classifying the packet to the net device that we wanted if the actual ingress port wasn't one of the net devices. We do not know at this point whether it is a specific host interface driver limitation or if it is something that SI never required, right? And I believe this, we ran into the same kind of an issue with lag as well, which is probably why SONiC went to use the bonding interfaces as opposed to the lag host interface from SI. So I must warn people that there was a restriction here that we ran into. We were eventually able to work around it, but if somebody is looking at this and saying, I could just use a VLAN interface to get it all working, it may not happen.
I think that doesn't line up with what our experience actually. Yeah,
so we saw issues on the receive path, not
okay.
On the
we can look into that.
Totally came in.
Right. We can check into that.
So the package totally came into the SI and the host interface, but it wasn't getting classified correctly. Right. So
I don't know
in
this proposal,
yeah.
So I mean, the question I have is in this proposal, Shrikant, what you tried this ASIC 0 CPU interface.
Right.
It's just a regular port host IF. Is it correct?
It is a regular host interface. Yes.
Okay. I think the difference is that in what we tried is a VLAN host IF because SOI supports it.
So we did try the VLAN host IF. The VLAN host IFs did not have a problem transmitting, but VLAN host IFs had trouble receiving if the ingress port net device, where the ingress port on the other ASIC was not created. Right. That was our experience with this. At least so that comes with full disclosure, right? We did get it working eventually. I do not know if we need to go into the details of how we managed to work it around, but it wasn't kernel. But the larger description of option 2 still holds, right? That we are not creating net devices for every interface. I believe it is possible to do so, all right? There is just one extra net device we create on the ASIC. I'm calling it CPU port here. The other options could be that somebody could have an extra port on the ASIC that could be used, or some ASICs may present other ports that are not visible on the network port as network ports that could be repurposed for this. Right. Now, the big difference here is the routes are all the neighbor is not written against the system port of the destination ASIC. The neighbor is created against this special net device, right? In this description, I'm calling it the CPU port of the ASIC. So if I look at the picture here, I think this is probably easier to follow from a picture and then go back to the table. If I go back to that example of packets, control packet flows between the ASICs, right? So here SONiC 0 is injecting a packet and it has to go to SONiC 1, which is this red line here. So it injects and the kernel picks this net device, which I'm calling ASIC 0 CPU. And when packets are injected on that net device into the ASIC, that will cause a routing lookup to happen in the ASIC. And the routing lookup says go to ASIC 1 CPU. It comes down here as a system port and gets ejected to the host and is received and is classified as being received against the ASIC 1 CPU. Our trouble, like I mentioned.
Question?
Yeah.
One question. Why does it have to be a routing lookup? Like it would just, why can't it just be a bridging operation?
So a couple of reasons, right? The SI VOQ specification did not complete the bridging portion of the spec. One specific portion that it missed out is that it did not define multicast tables that you need in the switch fabric for standard bridging operations to work, the flooding and all of that, right? You could work around that by using static MAC records, right? I mean, technically possible, right? So that was one caveat here, right? Is that if you didn't have multicast tables in the fabric and you're relying on things like ARP and others, they wouldn't work because the VOQ size specification did not define those tables.
Yep.
Right. So the other issue, so that has a practical workaround that technically somebody could create all static MAC records and work around. The other practical issue was that we ran into a real issue with SI host interface drivers, and that was a big problem. If you guys are able to disclose how you worked around it, we'd be happy to talk about it, but that's a different conversation, right?
Yeah, I mean, I think, so we have this HLD updated. I think it's a slight variation from this option 2 proposal, really. I think we can definitely go over that. I don't know when would be a good time to do that.
I think it's probably, let's go over, high level, finish it. I think there's only 10 minutes left, right? So I think I get this point. There's some subtle issues on how to receive that on the SONiC one. Yeah,
so
I totally get that.
I mean, at a high level, I can describe, and then we can, I mean, I don't know whether we have time to go over the flows, but at a super high level, I think the thing that we tried was creating we did not create the ASIC 0 CPU net device at all. We only created the VLAN net device, VLAN host IF. And once we created the VLAN host IF, we could add the system ports to the VLAN, which the current SI allows. And once we do that, then essentially the packet gets injected into the pipeline from the CPU, and then the hardware takes care of sending it to the other end. And we did not have any issue receiving the packet on the VLAN host IF because the packet will be tagged on, and then on the other side, when the packet comes to the kernel, because we created the VLAN host IF, it will be filtered based on the VLAN, and it showed up on the VLAN net device.
So there are so with everything I said, we've been able to work around this. Eventually, the answer wasn't a VLAN, but the spirit of option 2 was totally preserved, right? That we could do this.
Yeah.
Now, if I come back to these tables here, right? So this is a routing. So the key is that we were routing in the ASIC and delivering the packet out there.
Yeah.
Bridging, again, the reason we stayed, the two reasons I mentioned, the other was that we were trying to stay within the routing flows just so that we don't go into any unspecified behaviors, however small they might be. So looking at the tables themselves, you just have one interface for your own CPU, or it could be the VLAN, like we just talked about. The neighbor table itself isn't very different from what was there earlier, right? Except the destination net device for all the neighbor entries is your own CPU port. And in the SI, though, it looks totally different. In SI, it actually has the actual neighbor and the neighbor MAC and the actual system port, right? So for somebody wanting to compare what's in the kernel versus what's in the databases, what is in the SI neighbor table is what's in the database. And the Linux routing table had, like we said, it was pointing to the net device as the destination port, right? The /32 host routes. The quick parallel to this on front panel ports. Again, the same thing. Each ASIC has its own net devices for its own 2 ports on the network ports and 1 CPU port. The neighbor records are programmed very similarly, right? It's if it is a local neighbor, it is pointing out of the port, ASIC 0 port 1 or ASIC 0 port 2. Any neighbor originating from ASIC 1 or SONiC 1 is pinned against the CPU port. But again, the SI will totally have the correct information, the exact MAC and the port, right? That's what's delivered into SI. SI, I believe, ignores the MAC if it is not your ASIC, but it takes the port information. The Linux routing table is actually the same in both cases. There is no change in the routing table, right? Now, the packet flows themselves here for this is all the packets. If the packet is going out over your front panel port, it goes out exact existing system port behavior. It will result to the net device of the front panel port, get injected and go out. It is not doing any lookups in the ASIC, right? Whereas if the packet is going over the front panel port of another ASIC or to the CPU of another ASIC, it goes through the full ingress pipeline and it gets routed out of there. So in this case, this packet that's going out, say, over ASIC 1 port 1, or the fabric will carry the NCAP ID and will have its header rewritten on egress and TTL decremented, right?
So the one thing here I'm a little surprised about, I should say, is that when you inject a packet using the regular port host IF, it's at least the current implementation of the driver, I think, is just meant to not do any further lookup, right? It's bypassing the pipeline. Right?
So this
maybe that's
right. So I used ASIC 0 CPU. It's just one net device. I use the term creatively here. This could be just a VLAN with just that one port as the member, right?
Correct, but then I mean, the driver has to. I mean, the driver has a choice, right? When it's so for example, how does the driver do it differently between local ports and this port, right?
So yes, I should describe this, right? So this is so for the case where it is a VLAN, right? That VLAN has just one port member. So even though I call it ASIC 0 CPU, it is really the VLAN that has just one port member, right? So that was the thing. It could also be another in-band / a hidden port in the ASIC that could also come and help you here.
Understood. So I'm trying to differentiate how is this ASIC CPU or in-band, whatever, this one hidden port differ from regular front panel ports.
So if it is right, if it is right, if you create it as VLAN, it goes and does all the lookups, right?
Yeah, exactly.
Right.
Exactly.
So if you create it as a port that is hidden from the network port list or the front panel, then that port is like any other. I mean, anything that you sent on it would be treated as fully received on the ingress pipeline, right? Representing that port, and it would get all the ingress processing. So it depends on how that port is described, right? I mean, I guess without going into a lot of detail about the specific, I mean, my worry is that if I describe that clearly, some of that may look like a very ASIC specific implementation, right? I mean, if it is, so the VLAN one totally worked. I could put VLAN in ASIC 0 CPU, and that port is the only member of that VLAN. It works. The path out works. Like I mentioned, we had trouble with the packets coming in.
But even that, okay, maybe. So I mean, again, I understand we don't want to make it too architecture specific, but fundamentally, if any chip we use, if there are two different host IFs and they injecting packets into those host IFs, one of them skips the pipeline, other one doesn't skip the pipeline. We have to figure out how to differentiate them, right?
So I guess if you create the host IF as type VLAN, it doesn't skip the pipeline, right? If you put the host IF as type port, it skips the pipeline.
Got it. Okay.
Right.
So in this case, what would be the destination MAC address you send out?
So I think the destination MAC address will be the ASIC 0 MAC, right? It will put its own MAC in the destination.
Okay.
Because otherwise A60 will not route the packet, right?
Right.
That is a key point, and that is actually interesting, slightly deviant behavior from what a stack would normally do, right? Like slightly, you would actually put the MAC address of the next hop. But since we're doing another routing lookup here, and this is what Srikanth is getting at, it's slightly, it's not the mainstream approach. It is more like you are you're pretending as if the packet came in on a front panel port, right? So to preserve that pattern, you need to, if you received a packet, say on SONiC 0 port 1, you would have SONiC 0's MAC address as the destination MAC. Similarly, if you received a packet on the CPU port, you would have SONiC 0's MAC address, you would do a full routing lookup, and the packet would flow out. That's what I'm understanding. Correct?
Right. So the MAC, yeah, you're effectively asking your ASIC to route it. I mean, there are some real advantages with option 2, right? I mean, there's the, if you take full advantage of option 2, you could come and say, look, you really don't need any dynamic routes in the kernel. I don't know if we're going to go that far, right?
So one question. So when you
so I
say
do.
You had VLAN
yeah,
1
okay. Yeah, I get it.
VLAN 1 with a single port. It was a VLAN host IF then, or it's a regular host IF from the NetDev perspective?
So it's a VLAN host IF.
So then, what's the issue you faced on RX side? Like, because
so the RX side is
they were able to filter out.
So what I do not know at this point is if the issue is with the specific SI host interface driver we've been using with the ASICs that we got, or if SI host interfaces in general never supported it. When a packet came in on this port here, arrived here, and got ejected to the host interface driver was not able to classify the packet as being received on that VLAN. Right? That was the problem. That
it's probably a bug, right? Because
it can only classify it if it has a proper ingress, and the SI host interface driver generally seems to be classifying only up to the ingress and not based on the intended destination, right? That seems to be the issue.
I don't know the issue, right? Because that's how you expect normal Linux also, right?
Right. In Linux, you're right. It always puts the first net device it puts it on is the ingress, and then you build on top of it in Linux by adding VLANs or lag, and then it flows through the stack.
Because you want to know the RX port, right? Because it's not just destination port, because the packet, when it counts, you count towards where it's really received. Right. So I don't think it's a bug, but it's kind of expectation from Linux, but it's not really a blocker for us to get it work.
So the normal way to VLAN would be to do it outside of SI host interface and not do it inside SI, right? So
just time to check. I think I have a conflict, but I mean you guys can continue discuss, or do we want another sync tomorrow, or we wait for the next?
We are open with either. I guess depends on the group, right?
I think we got a lot of good momentum going. It feels like a good idea to have another sync tomorrow if everybody is free.
Yeah.
Yeah.
We
okay.
Can, we can discuss. The core group is free. I'm free. I can be available the same time. Between 9 and 11 Pacific is fine with me.
Yeah, work for us.
Okay, so I can.
Yeah. So I think just to kind of close it out, right? So basically, so I can completely see the intersection and the deviation between this proposal and the proposal I put out. So I think what we could do is complete just discussing how this would work, and we can immediately switch over to the relevant section of my proposal. I can talk through that, or Ishwar and I can talk through that, and then we probably in a good position to make an informed call here. Because and then we can then decide the mechanics of how to use
it. Tomorrow, what, 9 to 11?
Yeah, that's the window I'm available. Any window between 1 to 2 hours, whatever. I think one would be easier for me, but yeah, we can, if needed, we can do a 2-hour session as well.
Yeah, 9 to 11 is work. 11, we have a conflict. So
yeah, I think it'll be good to kind of hammer this one out before we go into the weekend. So if people are available for a few more minutes, that'll.
Okay.
Okay. So if 9 a.m. works for everyone, I'll send out an invite for 9. I'll block at least 2 hours in the meeting, and if we wrap up sooner, then we'll get the time back for the team.
Fine.
Okay. Thank you everyone for joining. We'll sync up tomorrow.
All right. Thanks.
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 Thank you.
Bye.
Right.